Hello and welcome, dear viewer, to another Serenity OS hacking video. So today I thought I'd do something completely different, which I've never done before, which is why I'm recording a video in the first place. That's usually how that goes. So on this page, this is my plan for Serenity OS. You can just open that on the internet. I will put a link in the description. On this page, there's kind of a plan. And like one thing that I put on the plan recently, which has actually been floating in my mind for some time now, was implementing some of the common nonlinear image processing filters for PixelPaint. There's a bunch of these here. If you know what they mean, great. If you don't know what they mean, don't worry about it. Most of them are not going to matter for this video, or you can just look it up on Wikipedia or whatever. They're just standard algorithms, very well known. And they're used for various kinds of image processing, mostly noise removal. And I've worked with them recently, so I thought I'd implement them, and I think I'll have to implement some new filtering techniques in Serenity itself, because they are non-linear. So you need to algorithmically look at every single pixel. You can't just provide a convolution kernel, for example. So enough theoretical talking. I'm going to implement the median filter today. And that one has a very nice and short Wikipedia article, which I've opened here. And basically all that does is in a limited environment or window or kernel. It's not a technical kernel from a signal processing standpoint, but it is a it is a region like a kernel. In that region, we take all the pixels around the pixel that we're trying to process and take the median of that region. And for example, for this 2, 3, and 80, see the median down here, which is 3. And that is now the new pixel for this location. That's literally all we do. You might know filters that take the average, which gives you some sort of smoothing, and this also gives you some sort of smoothing, but instead of just taking an average, we're taking the median, which is slightly more involved, but actually can give you better results. For example, these are some examples on filtering some basic images. One important thing about the median filter is that it still preserves edges in most cases. You can see even with a very large median filter, it still preserves these edges around the bear's nose, which is a really cool feature to have for this filter. And it says here that it's very suitable for then apply something like edge processing or some other computer vision thing. So I think also just visually it looks very nice. So I think it would be really nice to have in PixelPaint. Okay, for that I've already kind of prepared myself. Now let's see whether I can open the terminal with my shortcut. Oh, there it is. Oh, we're already compiled. Great. I didn't actually know whether I had already done that. So let's see. I want to actually test whether my 2 test images are openable in Serenity, because they are PGM images. And I'm not entirely sure how good our PGM viewer is. So those 2 images are standard test images that I have. One of them is I did put on some noise manually, and the other one is just a standard test image that is noisy in and of itself. So I think it's a great way to test that. I think they're all public domain. You can just find them on the internet if you really want to. So let's look into images. So most of them don't matter. The ones I'm talking about is Peppers and Barbara CRN20. Which I think means a standard Gaussian noise with a standard deviation of 20. I don't actually remember. The good thing is they both open up flawlessly in Serenity, which means I should be able to import them into PixelPaint. Let's see if that works. And yes, PixelPaint can work with those flawlessly. Now let's see, filter gallery. And yeah, well, we'll put it somewhere here. I've looked a little bit at the code, but I'll have to search around a bit, and it's kind of a natural thing like you would go about implementing this. I'm very unfamiliar with the PixelPaint code base, so I need to look around. Anyways, if we want to, for example, if you want to smooth this, the first approach would be a Gaussian blur. Let's use something like 3x3. You see it gets blurry, but also we have like edge artifacts because the edges are treated as zeros, which is not very nice to see. I will probably look at that because like edge handling is a big thing in image processing. But yeah, as you might be able to see, I'm just going back and forth here. It gets less noisy, but it also gets more blurry, and median filtering and other filtering methods can avoid that to some degree. Okay, cool. That's as far as you need to know about the theory and why we want to actually use median filtering. I guess this is just an introduction to median filtering at this point. Let's actually look at some code and write some code. So I think, is there a filter? Yeah, there's a filter gallery thingy here, and I think that's just a window. Is it? Yeah, it's just the dialog. So of course, you know, Tobias did this very, very cool thing. I actually talked to him in person about this. He's very, very proud of it. Wanted this feature for a long time. It's really cool. Go follow Tobias on like whatever social media he has. He's an awesome dude. So anyways, I wanted to see where that is. I think is it in the GML? No, it's not in the GML. So I know that there's a list of all of these. The filter tree model. Oh, right, that's it. Yeah, so this programmatically fills in all of the filters, and the filters. Let's look at the fast box blur, for example. They actually do live in PixelPaint. I thought they lived in libgraphics, because as far as I can tell, like image processing is the domain of libgraphics. Let's see what apply does. Oh, so it's filter parameters, and here we go. Graphics spatial Gaussian blur filter, which is a generic convolution filter of some size. We're using size 5 here. And what does filter parameters do? It just indexes into the kernel. Oh, right. Is that spatial Gaussian blur filter? Filter parameters of type. So wait, what is even the purpose of this class in libgraphics? So that's basically just a dummy class. Just a generic convolution filter. Does this, wait, what does this even do? So yeah, generic convolution filter has a concept of a kernel, and it has apply with cache, and it can apply its filter, and it has boundary conditions. Yes, so that does things, but why does the spatial Gaussian blur filter not actually change any of the kernel parameters? Oh, it even has modifiable wrapping behavior. That's interesting. Anyways, I am surprised that this class basically does nothing. And what we're doing here is like implementing all of the stuff in spatial Gaussian. blur filter, or in this case we're making these parameters manually, which is, yeah, this is just a Gaussian. The sharpen filter, which is probably first order. No, that's actually that's a first order approximation of a derivative. I'm getting nerded out by image processing stuff here. Generic convolution filter. And that asks for the parameters. Sorry, I'm kind of tired. Okay, I'm confused why this is this, but I guess we can just like specify another template for our new filter, and we should implement that filter in libgraphics, or should we? Yeah, it's of course not a generic convolution filter, it's a nonlinear filter, and convolution filters are linear and also finite, which makes them FIR, finite impulse response filters. Or even more, finite impulse response filters. Anyways, like you get me sidetracked on signal processing very easily. Anyways, we need to implement an apply method, which I believe is that used somewhere. Apply a button. Let's see what done does. No, wait. Preview widget set filter. Preview widget set bitmap. Oh, here we go. Apply, which calls back into... No, it doesn't call back into libgraphics. Oh, it does. Yeah, so this does all of the undo stack things, of course. But that calls into the parents apply. Filter in PixelPaint. Not filter in libgraphics. There's something fishy going on here. I mean, filter is a richer class because it knows about all of the PixelPaint specific stuff, like an image editor for some reason. For whatever reason, that is a raw pointer. Oh god, I'm really tired today. What is going on here? Just the target. Also, this smells like pointer aliasing. Anyways, finding all of these strange things in this code base. What is this? Is this Serenity? I don't believe it. Anyways, so the filter was that the filter tree model. Let's look at the box blur, which is still a public filter. And that is, of course, a PixelPaint filter, not a libgraphics filter. Though, is there like any... Wait, let me see. Gaussian blur, maybe? Gaussian H? Yeah, that would be a good idea, thanks. They all just completely ignore a libgraphics filter, which has the facilities of applying a filter to a bitmap with a specific target area, with a specific source bitmap with a target area and some parameters. Wait, let me actually see. What are the names of those? There's no CPP file. Okay, anyways, like, I think I'm just gonna ignore this. Well, there is the Gaussian blur filter here, but that like does nothing. It has literally no properties. Okay, I think this entire thing needs refactoring. We need to like move all filters into lib graphics and like basically remove 90% of the wrapper code from PixelPaint, because in the end all a filter does is get applied to from a source image and writing into a target image, which is the API we have somewhere in here, which is the API we have here. Whatever that API does. Wait, let me actually see. Oh, that actually looks at, yeah, so that's a problem because that has a reference to the image editor and applies that to the current layer, if I see that correctly. To the active layer, yes, and also pushes onto the undo stack. Or like onto the edit stack so that you can undo it, just standard things for any sort of editing program. Yeah. I am extremely surprised as to why and how that thing does work the way it does. Maybe I need to talk to Tobias about this. Anyways, yeah, this is some interesting C++. I know this is valid C++, but it looks very surprising. Add filter node gets as a parameter type the filter type, and the filter type provides its apply method. Okay, I think I'm just gonna implement one of those. Let me close all of those. Don't think I need that. Filter params, I don't need that, I don't need that. Bloom filter. Cool shit. So some of those work through a lib graphics filter, but that's not a requirement. Yeah, so this, for example, does a bunch of complex stuff. Okay, let's just add a new class. So I think I can, these templated? No, they're not templated. Okay, so I can put stuff in the CPP. Let's make a CPP file. Not even gonna bother looking at the clock. PixelPaint filters. Why can't it find that? I'm not entirely sure. Anyways, license and library. Doesn't actually, or yeah, I read that correctly. Okay. And I need to filter.h. So let's, and actually I'm going to make this like generic from the beginning so it can work with like any size. So it's actually not templated. Okay. And before I forget, filter median LM filters median CPP. Okay. And so let's actually just grab ourselves the bloom filter. Oops. Just to get things started. we need this, we need a median filter here, we need median which does nothing special, and filter radius can be unsigned because it could never be negative, and let's use as a default a 2, which means 2 pixels. 2 pixels always includes the center pixel, so 2 pixels basically means 3 by 3. If you think about it, you take this number -1 multiplied by 2 and add 1 for the center pixel. So a filter radius of 3 would give you 5, a 5 by 5 thing, and 4 would give you 7 by 7. Yeah, so it's actually just squared -1, I think. Okay, so I can actually just, before I forget about that, filter size is just the filter radius times itself -1. Because it extends to both sides. Right, so that's actually times 2. It extends to both sides, but the center pixel would be doubled in that case, so we need to subtract 1. Okay. So now we can actually already do that into blur and sharpen. We want filters again, and let's hope it imports that correctly. Yes. Okay. Great. Let's actually write the settings widget first. Then we can already check that, or let's actually just implement all the things so that and void the source bitmap, and return. I mean, yeah, it doesn't matter. I just know a ping. No, that should be correct. Oh, it's const. Of course, that makes a lot of sense. Ref per of GUI widgets, so GUI widget get settings widget. Wait, median. Is that thing const? It probably is. What is Clang do doing? Okay, nothing actually. Yeah, so we need to, just for good measure, let's do like GUI widget here. And yeah, I think that's all we need to implement, those 2 functions. So what does Bloom do here? In the settings, I think it creates a new settings widget, right? No, it actually stores one. Why do I not see that? Is that in filter? Wait. Oh yeah, oh, okay. Great, so we can actually just we can just if the settings widget doesn't exist yet, we created equals is it construct? Can I construct that? Yeah, I can, right? Let's just lower that from GML. Let's call that the median settings. Now I need to think about how to do the entire GML thing, which, to be fair, I've written the current GML parser, at least like, I don't know, 80% of it, minus all the bugs that I introduced. So I should know how this works. But okay, so we need a GUI widget on this root. I'm probably doing this wrong. No, I'm doing this correctly. Actually, that's a good idea. First of all, before I do too much of this, let me actually compile a GML, and we actually have a different kind of naming for that. So it's actually filters. Yeah, it's filters, median settings, filters, median settings GML, and the value will be called median settings. So yeah, median settings GML. So I can, in here, I can just get rid of this. Include applications, PixelPaint, filters, median settings, GML.h, and put a GML in here. And now let's quickly, wrong key binding, let's quickly run a build so that the GML appears. It did not appear. Oh shit, no, I totally forgot. I need to put that in the source because it can't find it otherwise. Oh my god, that's dumb. That's like a lot of time wasted. I'll edit this out. Features. So I didn't do this before. And now I'll try the subdirectory again. Because that just makes shit too crowded. Slash filters. Come on. Oh, I hit a rebuild again. Ah, it doesn't matter. So it does that quickly. If the damn CLDR downloads fast enough. It did a bunch of generating. Yeah, finally. Finally. No, this should actually compile. Let's not do a rebuild again. I'm just gonna keep it compiling in the background, just so that so now we have this. Yeah, so just that we later on don't need Ccache. Okay. That's a vertical box layout. Also, by the way, why is my highlighter not working? Maybe because I wrote the highlighter and it's dumb, I don't know. Honestly. I'm not entirely sure why it broke. Does the IPC... Might not be what happened. Although that works. Okay, interesting. Anyways, we need a text. Actually, let's do a horizontal box layout. Then let's just have a label with a text of the filter radius, and then there's like new sizing options, I believe. Like there recently was some addition to dynamic layout. Let's actually do some proper dynamic layouting. I know that there's documentation in the man pages, if not entirely mistaken. Is that 3? I've worked on this. I should know the man pages, but I don't. Now here we go. Regular grow, opportunistic grow. Shrink. Grow exactly the size of the surrounding is determined. Shrink. Can I just what? Shrink. Can I just do that? Oh, here, yeah, it's quite still. Should probably work on that. Would be a bit nicer. Now that is a strange way of putting that. That only works in Serenity. Yeah, that's not a relative thing either. It's UI dimension. Yeah, okay. That should work. So I should be able to say with shrink, and then we can say GUI input box with a name of filter radius spin boxes, that is. Do we have spin box documentation, min max, min 1 and max. That's just, I don't know, 256. That's pretty. Oh wait, no. Maybe for large images it would be 4096. I don't know. 1 page. Spinbox probably inherits from other things. It only inherits from widget, so it only has the min and max. and also the value. No, it doesn't have any way of setting the default value, so I'm just gonna leave it like that. Okay, interesting. Okay. I think that is enough. If I have a name, min and a max. I mean, 4096 is double that, so it should be 4095. Or, I don't know, just 5000. I mean, it's really is arbitrary. Should say settings widget dot what is that? Find child, a descendant of type named GUI. Oops. Spinbox of name filter radius. My brain is slowing down. Filter radius. Yep. Clang these tracks again. I know there's a setting for this. Don't tell me in the comments. I am not going to change it right now. So dot on change equals a thing which just sets the filter radius to the value yeah. And because this is like persistent, like this filter sticks around and its settings stick around, I think if you change the setting once, it will actually stay, and the next time around you use the exact same setting. Okay. Filter radius. Yeah, so I think all of this should already be testable. So let's see how that goes. It shouldn't do anything, but it should it should also allow me to open the the window if I'm not entirely dumb in how I wrote this GML. Also, I should turn off the annoying messages. Wait, no, they disabled them. Did they? What happened here? Config server crashed because... What the hell? Okay, what the hell? Excuse me? Excuse me, config server. What happened? Let's try that again. That was a full rebuild. Did I break something on a full rebuild? Let me actually check. Yeah, I'm on master. Okay, someone broke the entire system on master. No. Okay, now it works again. That was strange. Anyways. How did I do that? I think I can just PixelPaint images. Barbara? Yeah, I can. Cool. Let's see. We have the median filter. And we get the median filter radius. And we should probably look at the text align. Label. Text alignment. Text alignment center left. Okay. I can just delete. I don't know. Media filter radius 20. Apply. Nothing happens. Great. Let's implement the filter. And let's hope that I did the small visual adjustment correctly. Get rid of all of this. So if the target and source are the same thing, that's a problem. However, let me actually check what content bitmap does. Oh god, it just gives me reference to the content bitmap. A const one in one instance, and a non-const one. Like this is const. This is const incorrect, right? This is like incredibly const incorrect. Oh, wait. What does the Gaussian blur do? Does it override in place? It overrides in place inside the inner loop. Help! I am naive. Well, yeah, pretty hard to not make this naive, or rewrite it in a canonical way that allows it to be vectorized, because all of this should be like code that should be vectorized, and you could throw the entire thing on GPU. It doesn't matter. Wait, render target bitmap. Or from a cache. If source is different from target. Allows us to modify blah blah blah. The cache. Yeah, okay. Yeah. I get what they're doing. So you do actually need to make sure, like, but that is kind of ridiculous, that you need to make sure that these pointers are, like, you need to assume that these pointers are aliased. And it's not the responsibility of the caller, but it's your responsibility to work around aliasing. That's just dumb. Like, that's just plain up dumb. If I wasn't paying attention to these kinds of things, I would have just overwritten the target bitmap as is. I would have gotten horrible artifacts. Okay, let's do this the proper way. So let's do an auto target is the source bitmap cloned. That needs to must. Not just and then in the end we will target bitmap equals target. Probably to reference that. That's not a copy assignment, that's a move assignment. Are you fucking kidding me? Yeah, things ref counted. Well, that's interesting. Come on, show me the constructors. They're all gone because of ref counted, probably. Ref counted. Yes, the ref counted deletes all the constructors. Even the move constructor. Okay, so what that means is that what does generic convolution filter do? Like cache target. Yeah, like come on. Like come on, this is dumb. Like if I could just move the damn thing into the other, I would just have to probably just have to move the image data pointer, which is basically free. Like, how is bitmap implemented? I just had that open. God, I'm getting angry at the entire design here again. What is even happening here? Let's see. Well, we have an anonymous buffer. How about we just move over the anonymous buffer, because all the anonymous buffer contains is a goddamn frickin' through 3 layers of indentation, a goddamn frickin' pointer. Yeah, if you can't tell, I'm pretty angry at this design at the moment. It even has its own data pointer. Okay. So how about... Oh, wait, I can just grab the internal buffer. Well, that's private. I can grab the buffer. I cannot move out of it. Well, who can stop me from just like, is this class ever used in the kernel? I hope not. Try create with anonymous buffer from serialized byte buffer. Clone. Well, I can. Bitmap format. Yeah, the thing is, of course, allocations. But if I can just avoid allocations, I can just deallocate. Maybe that should work. Let's just fuck all of this. Bitmap from a bitmap. Move bitmap. Yeah, so of course ref counted does the entire thing because ref counted is ref counted. I guess this will create problems with ref counted bitmaps. Yeah. I mean, that's a thing of having the thing behind a pointer in direction. That the question is, why am I getting a reference here and not a full-on... Why am I getting a reference here, or wherever that was? Why am I getting a reference here and not a full-blown ref putter? That's the other question. I could just make it into a ref pointer and just serialize to byte buffer, which probably incurs a copy. It incurs a copy. Yeah, there's pretty much no way to do this. Like this clone, I can't really pull the damn thing out of the ref putter. It's without like crashing on some assert which checks the ref count, because that's what ref counted gives you. It gives you a first check on the ref count. I could show you that if I manage to find the implementation. Just a second. Let's look into here. Unref, which is called in the destructor. Yeah, well, you can see right here, it verifies the ref count, and this trickles down to all ref counter classes. It's fantastic. It's absolutely fantastic. By fantastic, I mean it's a dumb design, and all that needed to change was for this to be an actual pointer instead of just like an actual smart pointer instead of just this strange reference. Let's just fix me. Can we move the target data into the actual target bitmap? Can't be too hard, right? Okay, so let's actually target bitmap. Can I not graphics? Where's blit? There must be a blit routine somewhere. Oh my fucking god, there's no blit. I just Control T, that's it. But the graphics painter blitz. Painter blitz a source bitmap onto the painter. Okay, so auto painter for the that's graphics painter painter of the target bitmap, and then we just say painter blit at int at 0, 0 the target onto target rect. Let's hope that the default constructor for int point creates point dot cpp. What the actual fuck? Here we go. The actual default constructor. Blah 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 blah. Yes. Thank you. Okay. So I think like blit, first of all, I think that's in an O3 compiled. Yeah, it's in an O3 compiled file. Second of all, where was I? And second of all, it does a bunch of smart stuff to be fast, as far as I can tell. Like, I mean, also this should be a loop. Let's see. Yeah, I hope those loops are vectorized on O3. So, I mean, there's nothing better I can do. This is the best blitting routine we have on the system. Okay, so now that we have a target, we can actually write into it. So for int I0, like I'm already at like an hour and I haven't even written the actual code. Dot width. I'm just gonna call that x because who cares? For int y0 0 y is less than target bitmap height, increment y. Now let's see the actually I'm just noticing, why is this entire interface so small? Interesting. Okay, yeah, maybe I had the entire interface on too small for the entire video. Anyways, so let's see, we need the top left edge, which is exactly minus the filter size. The filter radius. Yeah, subtracted the filter radius. Wait, no, if the filter radius is 1, then we need the current pixel. So we need filter radius minus 1. So left is x minus filter radius plus 1. And the top is y minus filter radius plus 1. Filter radius. Oh no, minus 1. But for whatever reason, it's trying to unsigned int those. It's just int. Okay, so also filter size, just that I don't have to call the function 10,000 times. I'm already missing Jagd. Okay, so let's for I starts at left, I is less than left plus the filter size plus I. If you think about this mentally, it should be correct. Why? Oh, it's depromoting it to unsigned. Fuck my life. This should be an int, please. Yes, static cast int that. Damn you. Okay. For int j is starts at the top, and j is less than the top plus the filter size. Now let me finish my sentence again before Clang D interrupts me. If you think about this with filter size 1, then left will be exactly x and top will be exactly y, and the filter size is 1, so we will have exactly one iteration of this loop before I need to change my indentation to 4, and then I can continue. Yeah, so we'll have one iteration of the loop, and that's that. And on the second increment, the second condition, stop condition, will not hold anymore. Okay. And if we have -1, if we have 2, then we're doing -1. And the filter size is going to be 3. So it will be less than left plus 3. So it will be middle plus 2. So middle plus 1, or x plus 1, or y plus 1 will be the last one visited. I think this is correct. Okay. Vector of type color, I don't know, probably. Okay, so now the question is, where do we median filter this? And like, how do we deal with color? Like, generally, we just concern ourselves with gray values because that's how image processing goes. But let's actually have a inline capacity of 16 for like all the small filter sizes, up to 4, of course. Yeah, so we can, I don't know what the common technique is here. We can, I guess we can sort by brightness. Like, take the value with the average brightness and then replace the pixel with that brightness. So we're not considering color, but we're using the entire color value. Or we could do the entire thing for all colors separately, which I think can give weird results. On the other hand, I don't know what that Wikipedia page is doing. Yeah, it doesn't say anything about light filtering. Sorry, color. What do they do? Well, I guess we'll just have to try and find out, because I don't actually know how it works on color. I mean, I guess if I do actually zoom in a lot, do we introduce color fuzziness, or is that part of the original image? Let's actually go with the gray value for now. So let's say values dot unchecked append, which unchecked append means it doesn't try to resize, which means we need to set the size beforehand, but we know the size. That's not a problem. I mean, we could use fixed array at that point, but I don't think fixed array is sortable. I'm just a fixed array enjoyer. We need to append the source bitmap at I and j. And there's probably a different API for that. Is that get pixel at I and j? Yeah, x and y as expected. Values dot resize to filter size times filter size. I'm just gonna fuck you, client D. I'm just gonna cast explicitly. Oh yeah, fuck off. I'm just gonna cast here because nobody's gonna tell me otherwise. Anyways, values unchecked append, then we need to sort them. Is there no sort? Quick sort. Sort. In a K. Quick sort. Need to actually quick sort the values. can just get that from AK Quicksort. And it's actually a dumb idea to quicksort here. We should actually be insertion sorting, because that's much faster on small sizes. And I had a PR that added insertion sort as a like small chunk sorter as part of the bigger quicksort, and that thing, nobody cared about that PR. And if you ever want to annoy a contributor, a maintainer, sorry, please annoy them about that pull request. It's been finished for like 2 months or something. Anyways, now we have a quicksort. Fix me if there was an insertion sort in AK. We should use that here, because again, all of this code is kind of performance critical. If any of this code is slow, then the entire like this is not a fast filter. It's a slow filter, and anything I can do to make it faster, I will do. However, like I need a insertion sort, and I need all of that sort of stuff. And I'm doing a bunch of moving here, and I'm using what is it, vectors here? Yeah. Anyways, so we quicksort the values, and then take. We need to actually quicksort the values by a different. Is there like collection? And yeah, here we go. But that won't work. Like, I don't think color has a natural order, and I actually want to specify the order manually. RGB, RGBA, HSL. Hahaha. Bunch of conversion routines. Where's that? Lightness. Also, who capitalizes all of this stuff like that? Blend. Interesting. Luminosity. Yeah, I think we just want the luminosity. Const expert conveniently. Or to grayscale, which does the exact same thing. Yeah, so want check the A B here. Return A dot velocity is less than B dot velocity. And then we can take the target, set pixel at XY to the values, index values dot size divided by 2, which is the median. So essentially, yeah, I'm just looking at the Y channel at this point. YCBCR, fun stuff, color spaces and shit. Okay, this should work. If I have not entirely fucked up my life, it should work. And I'll probably need to enter my password again, because I've been writing code for some time. So did it? No, it didn't. Images, Barbara. Now let's try and filter Barbara with immediate filter. Let's see, the crash, it's probably just... yes, because I thought about it when writing the loop and then I forgot. Let's see. That should be median 28. It is. Okay. If j is less than 0 or I is less than 0 or j is less than greater than or equal to source bitmap dot not size in bytes, just j is y, so that's the height, or j is greater than or equal to the source bitmap dot width, that's I, then we just want to continue, because that is, in my opinion, the best edge behavior. Just ignore all the like, just don't deal with any data that would be outside the image, and just treat it as though the kernel is smaller in that case. Like the preview is quite nice, but I must say, Tobias, this is a heavy filter. The preview is gonna slow down the entire program. But oh well. There's some redesigns in store there. Median filter still crashes. I was basically anticipating it at this point. Never works at first try. It still complains about size plus 1 is less than equal to capacity. It's an unchecked append. Left plus filter size. Oh, I didn't resize. I had wanted to ensure capacity. That's what I wanted to do. Because otherwise I need to like compute indices and like in the example, where's that? Here. Like they're computing indices here with another loop variable, which is just no, I don't want to do that. Okay, filter gallery, median filter. Yay! Okay, that very much looks like it worked. I mean, maybe you can't tell, but I can tell this kind of look that only happens with a median filter. Okay, let's try the peppers. Let's try some images that I didn't specifically prepare. Like this one is kind of noisy, but also kind of not. And of course it will work very well on those because they're... Oh god. That's... Sax just crashed. Anyways, so I know these kinds of images work pretty well. Let's make the thing very large to see the preview. Median filter. Actually, it's surprisingly fast. Though I'm not sure if it's updating. No, I don't think it's updating. Because now you can see it takes some time to compute that. I mean, that's kind of expected. I think I need to like update the update preview. Okay, that's easy enough. Fun stuff. see if our scheduler likes that. Let's see if I can profile that while it's doing its thing. Let's see how many seconds that I will actually take. Otherwise, I'm just gonna start writing up a commit message. Let's see. Okay, let's just start writing a commit message. This is taking a long time. Filter tree model. I need this. I need this for the median settings. I actually want to move that thing down. That was just for like witchcraft or whatever. I want this, and I do want this. Look at the flame graph. It's spending a lot of time in quicksort. I wonder why that is. Okay, I'm actually laughing at this. Like, this is exactly what I would have thought. It's like 0 surprises. I think I might need to kill that program because it's taken me actually too long. Can I just delete? Yeah, I can. Oh, it finished. I think it realized that I wanted to kill it. Okay. That is cool. I like that. Looks spicy, dare I say. Get it? Because it's peppers. Looks spicy. Oh my god, my sense of humor is down the drain. Here, before, after. Let's actually add a new layer. Can I open a file as a new edit import? Is there like image? Wait, okay, so if I add a new layer, can I just like put an image onto that? Wait, let me check. I thought PixelPaint was such an advanced, cool application. Yes. No. Can I Control Z that? Okay, I can't. Now it's gone. Sad. Anyways. Oh, wait. Oh, wait, no. It's just a separate tab. Oh, interesting. I'm just actually incompetent at using... Let's open the peppers again. I'm actually just incompetent at using the thing. Okay, so... Copy and paste. So remove that layer. And now what I wanted to do is like do this. Like now you can clearly see that it's keeping edges. And that's not something that would happen with Gaussian and blur, and specifically it's keeping edges or areas that are larger than the kernel. So in this case you can see like the 32 pixels are crossing over here. So that's why this area is getting removed. Very cool. Very cool indeed. Let's actually grab Barbara. Well, let's grab the original peppers again. Let's throw on. Okay, wait, now the... Oh no, right, because I haven't done the update yet, so it's not laggy actually. actually do that to resize it. Let's just do like 4, 3 or 4. Yeah, that looks quite nice. Let's try that again. No generic convolution. Median filter of size 2. Yeah, you can see with like a median filter of size 2, it's just like removing some noise. I love it. It's amazing. It took me like 1.5 hours to do this, but I mean, results are results. Like, can't argue with the results. That's the saying I'm getting at. See the difference here? Sort of, kind of. Very nice. Okay. I think I can just commit that. I'm just gonna assume that this small change is good as is, like the update preview thing here is good as is. So I am not going to bother. Okay. PixelPaint, add median filter. Median filter replaces a pixel with the median of all pixels using gray values used in a this is a standard image filter used for denoising as this simplicity. It can, for example, retain edges quite well. The first implementation is quite inefficient, mostly to environmental constraints due to how images are passed to the processing function. An unnecessary copy necessary copies happen, and because there's no fast sorting algorithm for small arrays yet, quick sort is to be used, which is quite slow on this scale. I'm not saying that it's not asymptotically faster than insertion sort on the average case. I'm just saying that it's quite slow on this kind of scale because of all of the recursion and stuff. Like you can read up on that on the internet. Like you can look at intro sort and that sort of stuff. Like sorting is not a solved problem by any measure. And like whatever your teacher told you about quicksort, it's the fastest algorithm. It's not true. It's true for some very specific circumstances, and this is not one of them. Okay. So it's okay. Yeah, so I need to, oops, that was an Alt tab. I wanted to Alt Q that. Okay, I think that's all. Let me actually try a color image before I go. Let's try this, I don't know. This is a QOI image. which I have used as my profile picture in the past because I'm funny, apparently. Let's try median filtering that with size 3. Okay. So that actually kind of works. I mean, yeah, so, I mean, you could argue about what you wanted to do exactly, but I think for the most part, that's good behavior. It's not doing the exact correct thing, but I mean, there are several approaches, and we might want to allow the user to choose one of them in the future. I mean, the other thing that I am choosing for the user right now is boundary conditions. You would want reflecting boundary conditions, or the boundary, or like outside the edge is all zeros, so on. We could have that as an option for the user in the future. On the other hand, like most of the other filters don't provide that sort of control. On the other hand, yeah, like the sharpen filter just doesn't, and those blurs all just, yeah, they don't, I don't think what sort of boundary conditions they have. You might want to look that up. Yeah, and it looks like they have pretty bad behavior around transparency, which means transparency is treated as black stuff. So mine is, I think it's better in that regard. At least it appears to be. After all, we're copying the transparency of the other pixels. So as you saw here, these blurrings like copy transparency, which is quite nice. Like it doesn't destroy the transparency look entirely, just partially. Okay, anyways, thank you very much for watching. I hope that was a fun episode. Like, maybe you wanted more visuals, but I only got some visuals at the end when I got everything implemented correctly. I hope you liked this image processing thingy. Until next time, goodbye.